Hello, welcome back to Path to Programming. Today we're going to talk about how to use loops in Python. Before we get started, just a quick reminder about the platform that we're using to write all of our code. It's called replit.com. If you look in my URL, you can see that I typed replit.com. And if you want a reminder about how to use it, in our first tutorial, we broke down how to create your own environment and the three different sort of things that you see on your screen: the file directory, the main text file, and the console. So if you want a reminder about how to get here and how to actually start writing code, go back to our first tutorial. But today we're going to talk about how to use loops in Python. Loops are essentially a programming tool that we can use to give a computer an instruction and tell it to repeat something multiple times. So say, for instance, we wanted to tell the computer to print hello 15 times. We could put it in a loop and the computer would know to print hello 15 times. So there are two main kinds of loops in programming, and we're going to talk about both of them today. The first is the for loop. And so the actual syntax for a for loop is written as for, and then typically the variable I is used. So you could say for I in range, and then we'll pass in the number 5, and then a colon. And so remember, in programming, whenever we see those two parentheses, we know that we're going to invoke a function. And so in this case, we're invoking the range function, but let's break down sort of what's happening on this first line. We're telling the computer, let's look at this variable I, which hasn't been initialized. We haven't given the computer any value for I, but it just kind of knows because the for loop is such a big part of programming, the computer automatically initializes it to 0. And so it's saying for this variable I in the range 5, I want you to execute a certain number of actions. And so in this case, let's make it something simple, and let's just print I to see what the value actually is. So if we run this program, you can see the numbers 0 through 4 are printed. And so this is a core part of programming that you have to remember that in most cases, we're going to start counting from 0 and not 1. And so what that means is that we still print 5 things to the console, but we're not printing the numbers 1 through 5. We're printing the numbers 0 through 4 because in this case, the computer is asking the question, is I less than 5? And so basically, the first iteration of the loop, or the first actual time we go through the loop, I is 0. So 0 is less than 5, so it works. 1 is less than 5, so it works. 2 is less than 5, 3 is less than 5, 4 is less than 5. But then when I becomes 5, the loop stops. And that's simply because 5 is not less than 5. So it's not going to iterate that 5th time. And so the really cool part about for loops, the built-in part, is that I will continue to increment or increase itself by 1 every single time we go through the loop. So the computer will check, okay, I, which is 0 in the first instance, is I less than 5? Yes, it is. So we're going to print I. And then after that, no matter what code we write here, it's going to increase I by 1. So I becomes 1 after that first iteration. And then we check again, is 1 less than 5? It is. So we print 1. And then we increment it and we say, is 2 less than 5? Is 3 less than 5? Is 4 less than 5? And then finally, when we get to 5, we stop. But that's sort of the basic example of a for loop. If we wanted to, we can change I to hello, like the example I was talking about earlier. And if we run this program, hello is printed to the console 5 times. So you must notice that the program is still going to print 5 things to the console. It's just that the index, the actual value of I is going to start at 0. But whatever we put in this range, that number, the loop is going to execute that number of times. So if we put the number 10 in here, the program is going to go through the loop 10 times. It's just the way it does it is by starting at 0 and counting from 0 to 9. While 0 is less than 9, and we keep adding more numbers. So if we run this program, you can sit here and count them, but hello is printed to the console 10 times. So this range function in Python actually has a couple more interesting features about it. We won't talk about everything here, but we can talk about sort of 2 big ones. We can talk about how if you want to put in another argument here, and remember, arguments are just the things that we can pass into a function. So if we put in another argument and let's say we pass in number 2 and then a comma, because for all the arguments you pass into functions, you have to separate them with commas. So if we pass in the value 2, this is telling the range function, okay, I want to set the variable that we're counting with, I want to initialize that to 2, and then I want to count all the way up to this upper bound. So now if we run the program, or let's actually change it back to I. So if we run the program, you'll notice that we actually start at 2 now. So what we told the program here is I want to count from the range 2 to 10. So now, instead of iterating from the value 0 to 9, we iterated from 2 to 9. So that's just one interesting feature about it. You can also change the amount that I is being incremented by. So let's say we wanted to count from 1 to 10, 1 to 10, and we wanted to increment by 2 every single time. If we run this program, you'll see that the amount that I is increasing by every time we go through the loop has changed to 2 now. Previously we saw it do 0 through 9. Now we're seeing it do 1 through 9, and every time we go from like 1 to 3 to 5 to 7 to 9. And actually, to make it more accurate, I could change this to 0, and then we see that it goes 0, 2, 4, 6, 8. So that's sort of the basics of the range function and the for loop in Python. There's sort of one more thing that we can do with these for loops. And if you remember back to our data types video, one of the data types that we talked about were strings in Python. And again, those are just the things that were stored inside the quotation marks, and we can put anything we want in there. So let's create a variable called fruit, and let's call it apple, or let's assign it the value of apple. And one thing that we can do with Python is say for I in apple, or in fruit, sorry, colon print I. So you might be wondering, how would this work? Because there's no value initially. There's no, like, you can't start at 0 and count through a variable, right? So what the program is going to realize here is that fruit is a string. Fruit is another variable. And so what we can do is we can iterate through all of the different characters in that string and print them out. So if we run this program, you can see that we print the letters that are in apple. And so this is a really cool feature in Python. Some of these things are a lot harder to do in other languages, but Python makes it pretty simple. We can iterate through all of the different characters inside of a string, and we can do a lot of cool things with those. But that's the basics of a for loop, and things will get more complicated later on when we start implementing for loops and using them in specific programming problems, but that's the basics for right now. Now we can talk about the second kind of loop in programming, which is the while loop. So the actual syntax to write a while loop is just the word while and then a condition after that. If you remember back to our conditionals video, basically conditionals, we're asking a question. We're saying, is this true? Is this false? And so we can do the same thing here. While a certain condition is true, the loop is executed. So to sort of replicate the loop that we made before, let's say, or the thing is with while loops, things aren't built in. You can do a lot more things with while loops. So there isn't automatic incrementing of a variable. There isn't an automatic initialization. So what we can do is just say, well, we can create a variable called I, set it equal to 0. And then we can say, well, I is less than 5. And then we'll print I, just to sort of make it the same thing. And I'm going to go ahead and comment these out. And remember, comments just are something that we can do to programming lines or in our code that we can ignore the use of them. So the computer is going to start running and it's going to ignore all these lines because they have the hashtag in front of it. And so it tells the computer to ignore those. But if we run this program, you can see, oh, sorry, that's actually a key part of it. So what we need to do actually is we can stop running the program. So while we're in the while loop, one thing that we need to mention is that there is no automatic incrementing of our variables. So since we initialize the value of I to 0, at the end of our while loop, we have to say I is equal to I plus 1. And so this is a really important part because in the for loop, we were just able to print I and the value was automatically incremented. But here in the while loop, we have to keep increasing the value of I so that the while condition is eventually met. because you can imagine if we have I equals 0, it's going to say, is 0 less than 5? And that's true. And then it's going to print 0. But then since the value of I didn't change, it's going to continuously ask the question, is 0 less than 5? And that's really bad. That's why in the console you can see it just continuously printed 0 and the program didn't stop running because 0 is always going to be less than 5. So I had to manually intervene and stop the program. But now that we've changed it, if we run the program, now we'll see the values 0 through 4 printed out. And so this is what you need to be really careful with about while loops. If you're going to be using them this sort of same way that we would use for loops to iterate through something and increment a value, you really need to be careful and make sure you don't forget to increment those variables so that eventually this condition of like while I is less than 5, eventually that condition is met. Otherwise, you are sort of stuck in an infinite loop is what we call it. So that's a basic example of sort of what a while loop can do. However, while loops have sort of more functionality. They give you a lot more flexibility in terms of things that you could do. So another example is, let's sort of build on some of the previous things we've done, and we can create a variable called response instead of equal to input, which again is another function that we covered in a different video. And you can pass in an argument of a prompt. So we can say enter a number, and then we'll say, and remember the input function returns everything as a string. So if we want to treat things like a number, we have to convert them to integers or floats or whatever. So in this case, let's convert it to an integer, and we'll say int response. We covered all of this in our input video, so if this is looking really unfamiliar to you, I recommend checking out that video. So this should work. So actually, oh, sorry, I wrote this wrong. So it should be int and then parentheses around the thing that you're changing. And then you want to say while, let's say, while response is not equal to 0, we can say, let's just print if the number is even or not. So let's check if response mod 2 equals 0, then we want to print response is even. And so if this looks really unfamiliar to you, that's okay. Basically, this modulus operator is checking the remainder. So this is sort of a more mathy concept, but basically, if you have a number, like let's say for instance 5, and you do the operation of 5 mod 2, then that would be equal to 1, because basically it's dividing the first number by the second number and taking the remainder of that. So 2 goes 2 times into 5, and then you're left over with the remainder of 1. So it's basically checking the number of whole times that this line on line 8 is checking how many times can 2 go into whatever number they enter. And so this is a really common way in programming to check if a number is even. So whenever a number is odd, it can't be divided by 2 evenly, which means there's always going to be a remainder of 1 left over for any odd number. But if there's any even number that we're checking, 2 can divide it evenly, which means there's going to be no remainder after we keep dividing it by 2. So that's just a little like sort of bonus thing. But basically we're checking while the response is not equal to 0, then we check the actual number that they entered as a response and say, if that number is, or if the number is even, then we can print it's even. And so you'll notice that we ask the user for a response first, and then we enter the loop. And that's because we need our while condition is what it's called. Our condition of the loop is dependent on having a response. If the user hasn't entered a number yet, we can't enter the loop. And so what that means though is that after we execute this statement, we need to ask the user for another response. So we can just copy and paste these lines down here again and say, yeah. So now we're going to check, is the response that they entered even? And then if it is, then we'll print response is even. And we can add an else statement also and just say print. Oh, it's a little messy. We can print response is odd, and then after that's done, we're going to check the response. We're going to input the response again, and the condition here is response is not equal to 0, which means whenever the user enters 0 as a response, the loop is going to finish. So actually, outside of the loop, we can add something else and just say print loop is finished, so that we know whenever the program is done, the program will tell us. So this is a little bit complicated. We've covered most of this in our other videos. We've covered conditionals in another video. And again, remember this equals equals operator is just asking the question. Typically, if we have one equal sign like we did on line 1, that's assigning a value to something. But if we have 2 equal signs, then it's asking the question. So if we take the response that the user gives us and divide it by 2, is the remainder equal to 0? And remember, the modulus operator is just checking the remainder after a number has been divided by 2 continuously over and over again. How many 2's can fit inside some number? So let's run this program and see if it works. And so yeah, so we get the response, or we get the prompt. So let's enter the number 5, and then it says response is odd. So immediately after it says response is odd, the program progresses down here again where it asks for the input. So let's enter another number, and let's say 4. Oh, sorry, wrong place. Let's enter 4, and then we hit enter, and then we see response is even. So now, after I entered a response, the program looped back up around and checked. Is the response equal to 0? No, it's not. So let's go check if it's even again. Then let's ask for the response again. So we checked if the number is even again, or even or odd, and it printed that 4 is even. And then now it's asking for a number again. So this time, if I enter 0, it should break the program. Not break the program, but just sort of break out of the loop. So if I enter the number 0, it's going to go back to the top and say, is response equal to 0? And in this case, it is true. Response is equal to 0. So it's not going to go inside of the loop, and instead it's completely done with that. And it should go to line 17, or just outside of the loop. And line 17 says print loop is finished. So if we enter 0, now we see loop is finished. So this is sort of a little bit more complicated. And so I suggest, if that was a little bit confusing, go back and sort of rewatch it and break down each of the parts. If the modulus part is a little bit complicated, that's totally okay. It's sort of a more like math specific thing that you'll see really commonly in programs that deal with numbers, or programs that want to check if something is even or odd. But basically, that's sort of the simple concept behind a for loop and a while loop.